2.3, which is simplifying variable expressions. I want to remind you about a few things about taking notes. First of all, remember I like to take notes in color. That's your choice, but usually if you use color, you help yourself you make things stand out so you can see it easier and remember things. You also don't just copy everything down on the screen. You make notes of things that I'm saying, things that are important to you. You make connections, you use arrows, all kinds of good stuff. Also, you need to pause the video if I'm going too fast and get down what's needed, rewind if you need. And when there are practice problems where I say pause the video, you need to pause it and do it on your own and then go back and check the work. It doesn't help you if you just have it play through without listening to me, or have it play through and not pause and try it out on your own. Okay, so we need some vocab before we start to make sure that we have this common language we're going to use all year. So the first one is terms of an expression. So terms of an expression are the parts of an expression that are added together, and those are called the terms. Now you may say, hey, Mrs. Wyman, what if I have a subtraction sign? So I'm going to just write an expression over here, 3x minus 8 plus 2x plus 5x. Okay, and you could say, hey, there's a minus sign there. If I change that minus sign to plus a negative, do I have all adding? Yes, I do. So it's adding or subtracting, because subtracting is adding the opposite, adding the negative. The coefficient of the term is the number in front of the variable. So any variable terms, they have a coefficient. In this instance, the coefficients are the 3, the 2, and the 5. Now, this problem, if I had stuck some more negative signs in there, I'm going to make it minus 2x and minus 5. I need to change those all to adding the opposite first, because the coefficients are the negative of those numbers. So the 3 is still a 3, but now it's negative 2x and negative 5x. So you have to make sure you're including those negatives. A constant term is a number without a variable. Well, we only have one constant in each of these. It's that negative 8. Negative 8 is the constant term. And then the last is like terms. Terms that have identical variable parts. Now, if there's more than one constant in there, negative 8, if there was another constant, it can't change, right? It doesn't have a variable. They would be like terms. There aren't in this instance. So my like terms here would be 3x, negative 2x, and negative 5x. So that's what we're going to do right now. We're going to practice identifying terms with this guy right here. Okay, so we're going to write the expression as a sum. So that's what it's asking you, is to change those subtractions to adding the opposite. Okay, plus negative 3, there we go. Okay, then this x, it's the same as 1x. So it wants you to make sure you notice there is a coefficient here. It's a coefficient of 1. So the coefficient of the x is 1. And now they want you to list out all the terms. So the first thing we do when we list terms is we write it out with commas now. So 5, negative 2x, not positive, negative 3, and 1x are the terms. Like terms, there's a couple pairs. The first pair of like terms is the negative 2x and the 1x. Or you could just write x. And then I have a semicolon, and my other pair of like terms is the 5 and the negative 3. Remember, if you would lose your negative sign there, that would technically be wrong, because that's a negative 3 in this problem. Coefficients are the numbers in front of a variable. So negative 2 is in front of a variable, and 1 is in front of a variable. And then constants are numbers without variables. They're constant. They can't change. So that would be 5 and negative 3 in this problem. Okay, so down here, what you're going to do is you're going to write out the 4 vocab: terms, like terms, coefficients, practice saying that word, coefficients, and constants. You're going to write them out using commas and the and signs like I did. You're going to list them out right now. You're going to do both 1 and 2. So go ahead and pause, practice 1 and 2, and then come back and see how you did. Okay, so the first one, our terms are 4y, negative 6, did you make it plus a negative, and 3y. There's only one pair of like terms because there's only one pair of y terms, so that's 4y and 3y. The coefficients are the numbers in front of the variables, 4 and 3, and the constant term, there's only one of them, it's negative 6. In this one, you're adding the opposites and also put a 1 in front of the W. So the terms are 9W, or 1W, negative 5, and negative 8W. The like terms are 9 and negative 5, and also W and negative 8W. The coefficients, the numbers in front of the variables, are 1 and negative 8, and the constant terms are 9 and negative 5. Good work. All right, so let's go to the next side. We're going to simplify an expression by combining the like terms. And yep, this is review from last year, so if your brain's going, I think I remember this, there's a reason for that. So what they want us in our first step is they want us to change any subtractions to adding the opposite. Well, I'm going to do it right here, but they're leaving a space over here to do that, so really that's the same as this negative 3m and the negative 7. And then any like terms, they're going to use the commutative property to rearrange. So that's why they put the negative 3m next, and then the 8 plus negative 7 also goes. Now, I'll let you color code. So if you don't want to write this step, what you can actually do is you can add the m's together, okay? And what is 5m plus negative 3m? What we're really doing here is we're doing 5 plus negative 3, and the m goes along for the ride. This is an additional step, too. You don't have to show that. This is just helping you figure out the math that's involved. So what is 5 plus negative 3? 5 minus 3 is 2, and the m goes along for the ride. It's like you have 5 marshmallows minus 3 marshmallows is 2 marshmallows. The other part of the problem is the constants. They are like terms. So 8 and negative 7 go together, and you just do that like normal math. 8 plus negative 7, you have $8, you spend 7, you're left with 1. So my final answer is 2m plus 1. And that's all I can do right now until someone says, hey, m is 3 or 7 or negative 22 or whatever. Okay, so we're going to jump down now, skip example 3 just for the minute, and we're going to look at checkpoints 3 and 4. I want you to pause the video and do 3 and 4 only, and then come back and see if you have the right answer. You can show all of this work, or you can just show the color coding like I did and get the solution as well as your choice. Okay, so pause the video and go ahead. Okay, so did you make it plus a negative 6? In this instance, you actually could have kept it minus because there were no other constants, but I have it as plus a negative. And did you notice 4y and 3y make 7y? In number 4, there are a couple pairs of like terms. The w terms, or the variable terms, always come first. Did you remember this was a 1w and this is negative 8? So 1 plus negative 8 is negative 7w. The plus sign continues, and then 9 plus negative 5 is 4. All right, so now these have something a little different, right? We're going to look at the examples up here. What do they have that the other ones didn't have? The distributive property, you got it. Now you're starting to figure out why we did all those properties in the previous unit. So the first thing I want to do when I see this is I'm going to make this plus a negative x or a negative 1x. I don't want to forget that, so I'm going to do it right away. They didn't do it in their example, but I'm going to add that in the work that they started over there as well. And now I'm going to distribute. So you need to be drawing your arrows in so you don't forget to do it to the second term, which is a pretty common mistake. So 3 times x, it's like 3 times 1x. 3 times 1 is 3. The x gets rewritten. Plus sign. 3 times 2 is 6. Now I'm back to what we had before, right? I have my like terms. What are my like terms? My variable terms are my like terms. Okay, so 3 plus negative 1 is 2x. And then my other like terms are my constants, the 6 and the 9. 6 plus 9 is 15. So that's my final answer. We'll try another one together. In this one, it is super duper duper important that you make this minus sign in front of the 5 adding a negative, because negative 5 is what gets distributed to both of these. And if you forget it's a negative, you'll end up with the wrong sign for that 4 times the 5. So I'm going to make this a plus sign right here because they didn't do that at first and they are going to possibly make a mistake. So that's just going to be a plus. They're waiting for us to do the problem. The 2k is not being distributed, is it? So it just gets rewritten. Negative 5 times k is a negative 5k plus sign, and now distribute. Negative 5 times 4 is negative 20. Once I'm done distributing, I have to combine like terms. So 2k and negative 5k make negative 3k. And then the negative 20, the plus negative 20, just gets rewritten. There's my final answer. Okay? All right, the last one is extra tricky. We want to make sure we master this guy right now so you don't have any problems later. There's a minus sign in front of this, but there's also a number right here. Can't you see it? What number is right there, in between the minus sign and the parentheses? What number? It's a 1. So I need to make that plus negative 1 because that negative sign is being distributed to both items in there. And I'm going to actually make this plus a negative 7 as well. Now they're leaving me some extra room here, and we're not going to worry about that. We're going to make this a plus sign, and then we're going to distribute our negative 1 through. So negative 1 times 5a is negative 5a, plus sign. Negative 1 times negative 7 is positive 7. And then you're going to combine your like terms. So 5a and negative 5a, they make 0a. So I don't even write it. 0 times anything is 0. It's gone. I'm going to write it here just to tell you that that's what it is. 0a. Ooh, what a mess. 0a plus 7. I don't need the 0a. I just need 7. So that one actually simplified to 7. All right, let's see how you did. We have 2 more to practice here, and then I'm going to give you one bonus challenge after that. But you're going to do 5 and 6, and then come back and see how you did. Pause the video. Okay, did you get 2x plus negative 11 or minus 11? I hope so. You needed to make sure you were prepping this problem by adding the opposite. You're distributing the 4 through to get 4x plus negative 4. It's not being multiplied by these two guys, so they just get rewritten. And then only like terms go together, right? So the x's go together to make 2x. The constants go together to make negative 11. In number 6, you should have gotten negative 1k or just negative k. You don't even need the 1 there. Negative 1k plus negative 18. We distributed the negative 6 through and got negative 6k plus negative 18. Like terms, that guy just gets rewritten. Okay, I want to give you one more. It's going to be a practice like C up here to make sure you've got this idea down. So we're going to number this one number 7. It's going to be negative 2a minus parentheses a plus 3 minus 4a. Okay? So what should we do first? Well, we got to take care of the minus signs, right? This one's already a negative, he's good. Plus negative 1 here, plus negative 4 there, and now we're going to distribute. The negative 2a just gets rewritten. It has nothing to do with the distributive property. This one becomes plus negative 1a. This one becomes plus negative 3. And plus negative 4a isn't inside, so it gets rewritten. It didn't get distributed to either. I have 3 pairs of like terms now. They all go together. Negative 2 plus negative 1 plus negative 4. That makes negative 7a. And then the constant is negative 3. It just gets rewritten. Okay, you should be good. So you're going to continue on to the next step right now. Good work, guys. If you have any questions, see Mrs. Wyman.